Need to test your FastMCP server with different Python versions or dependencies without polluting your main environment. You'll see how the FastMCP CLI handles isolated execution, letting you specify exact Python versions, inject packages on demand, or load requirements files, all while keeping your base environment clean. The examples will show you how to combine these options for flexible testing and deployment. Hash run with a specific Python version. FastMCP run server, PyPython 3.11. Hash run with additional packages. FastMCP run server, Py with pandas with NumPy. Hash run with dependencies from a requirements file. FastMCP run server, Py with requirements, txt. Hash combine multiple options. FastMCP run server, PyPython 3.1 with HTTPX transport HTTP. Hash run within a specific project directory. FastMCP run server, Py project path to project. This demonstrates the command line interface pattern for runtime configuration and dependency isolation. The FastMCP CLI acts as a process manager that handles environment setup, dependency resolution, and execution parameters without modifying your source code. What makes this distinctive is the separation between application logic and execution context, enabling reproducible runs across different environments. The pattern works by externalizing runtime concerns through command line arguments. Instead of hard-coding Python versions, package requirements, or transport protocols in your script, you specify them at invocation time. This creates a clean boundary where your server code remains portable, while execution details become configuration parameters managed by the CLI. The framework handles environment isolation automatically, spinning up temporary environments when needed. This approach solves the dependency management problem for deployable tools. It lets you develop with your preferred environment while ensuring clients can run your server with their specific requirements. The pattern is particularly valuable for distributed systems, CI/CD pipelines, or any scenario where you need to decouple code from its execution context. The trade-off is slightly more complex invocation syntax, but the gain in flexibility and reproducibility typically outweighs this cost. Let's break it down. Hash run with a specific Python version. FastMCP run server, PyPython 3.11. This enforces a specific Python version for execution. Critical for reproducibility, it prevents version mismatch errors by guaranteeing the runtime environment matches your development setup. Hash run with additional packages. FastMCP run server, Py with pandas with NumPy. This injects additional Python packages into the execution environment. FastMCP handles dependency isolation automatically, preventing version conflicts with your host system. Use this when your script requires packages not already available in the target environment. Hash run with dependencies from a requirements file. FastMCP run server, Py with requirements, txt. This loads dependencies from a requirements txt file, eliminating manual package specification. Perfect for complex projects where listing each package individually would be error-prone. FastMCP handles the installation and isolation automatically. Hash combine multiple options. FastMCP run server, PyPython 3.1 with HTTPX transport HTTP. This demonstrates FastMCP's composable CLI options, combining Python version specification with package dependencies and transport protocol in a single command. The Python flag pins the runtime version, with adds package dependencies, and transport defines the communication protocol, all orthogonal concerns you can mix as needed. This pattern enables precise environment control without modifying your source code. Hash run within a specific project directory. FastMCP run server. High project path to project. This sets the working directory for the FastMCP execution environment. Critical when your script depends on relative file paths or project-specific configurations, as it ensures all file operations resolve against the correct root directory. FastMCP runtime flexibility. The CLI's environment isolation via UV run subprocesses enables reproducible execution across Python versions, dependency sets, and project contexts without contaminating your local environment. Arguments after pass directly to your server's argparseClick handlers, but forget them and your configuration becomes invisible to the running process. This subprocess model is what makes "it works on my machine" irrelevant for FastMCP servers.
The server that runs, everywhere runs, nowhere you can see.